today we're going to look at factorising and solving our quadratics. Now you've got to know the difference between these two words. Factorise just means put it into double brackets, solve means work out the two values of x in this case. So we need to know how to put this into our double brackets, and there's one thing you need to remember: we are timesing to make this positive 6 and we are adding to make this positive 5. I now write down my factors of 6, which are 3 and 2, 1 and 6. Then we double check 3 plus 2 is 5, 1 plus 6 is 7. Okay, so we only ever get one solution there. Once we've worked out the two numbers, we can then just pop them in to our double brackets. So we've got x plus 3, x plus 2. Part B then asks us to solve this. So what I'm going to do is rewrite the answer which we've just got, which was x plus 3, x plus 2, and that is equal to 0. And now we need to solve it. So we need to make each bracket equal to 0, because if we made the left hand side equal to 0 here, 0 times anything is 0. If we made our right hand side equal to 0, 0 times anything is also 0. So we'd get our two solutions. So we're making each bracket equal to 0, which we can then solve by subtracting 3 and by subtracting 2. So we get our two solutions: x is negative 3 and x is negative 2. In question 2, it's very similar. They've just asked you to factorise. So we are timesing to make 16, we are adding to make 10. Again, you can list down your factors of 16. There are a few more here. Then you'll see only one pair would add to give you 10. So therefore our answer for part A is x plus 8, x plus 2. It has only asked us to factorise, so we are finished there. In part B, we're timesing to make 12, and we are adding to make 7. Again, we're going to list down our factors of 12. We've got 4 times 3, 2 times 6, and 1 times 12. Only one pair will work. We can then write this in our double brackets. We're going to have x plus 4, x plus 3, and then our final question, part C, we are timesing to make 12, we are adding to make 13. So we've got 2 times 6 is 12, 4 times 3, and 1 times 12. 2 times 6 doesn't work, 4 plus 3, and then 1 and 12 does work. So therefore our solution, x plus 1, x plus 12. So question 3, this is very similar to what I've just shown you, however this time it's introduced some negatives. So again we set out our table. We're timesing to make the number at the end, the 32. This time we are adding to make negative 12. So you can see you're timesing to make a positive number, however you're adding to make a negative. That is only possible if both answers are negative here. So instead of writing my positive factors of 32, I'm going to make sure they've both got negative signs in front of them. So we've got negative 16 and negative 2, negative 1 and negative 32, negative 8 and negative 4. So now I can add these together. Negative 16 plus negative 2 doesn't work. Negative 1 plus negative 32 doesn't work. Negative 8 plus negative 4 gives you negative 12. So therefore, we've factorised, and our solution would be x minus 8, x minus 4. Very similar process for part B. So we're timesing to make positive 48, and we're adding to make negative 14. So again, we know both answers must be negatives, so that we times to get a positive and add to get a negative. So minus 4 and minus 12, minus 2, minus 24, minus 1 and minus 48, negative 8 and negative 6. Now we can combine these together and you'll see that it must be negative 8 and negative 6. Our final question, part C, I'm just going to write down our answer. So we have x subtract 2, x subtract 1. Negative 2 plus negative 1 is negative 3, and negative 2 times negative 1 is 2. Question 4, again I'll show you the first two. So this time we are timesing to make a negative number, but adding to make a positive number. So because we're timesing to make a negative, we know one of those numbers must be negative. So here, negative 4 times positive 1. We then do the reverse of this. So negative 1 times positive 4. Negative 2 times positive 2. We don't need to do the reverse because it's the same, it's repeated. So now we will add them together and see which pair work. This gives you negative 3. This gives you positive 3. This gives you 0. So therefore my answer must be x minus 1, x plus 4. So in part B, we're timesing to make negative 3, and we're adding to make negative 2. So again, I know that one of them must be positive, one of them must be negative. So I write down my factors of 3. This one's quite easy because it's prime. So we've got negative 3 and 1, and negative 1 and 3. Negative 3 plus 1 gives me negative 2, and just double check, negative 1 plus 3 gives me positive 2. So therefore my solution would be x minus 3, x plus 1. So in part C, I won't talk you through it the long way, but we'll just write down our answer. So we'd have x plus 4, x minus 2. 4 times negative 2 gives you negative 8, and 4 plus negative 2 gives you positive 2. So question 5. This is a more typical exam question. It doesn't tell you to factorise here, it just tells you to solve. But in order to solve this, we first of all have to factorise it into double brackets like you've been doing, and then you'd work out your two solutions. So we're timesing to make negative 24, and we are adding to make negative 2. So we're going to write down our factors of negative 24. We know one must be positive, one must be negative. So minus 24 and 1, minus 1 and 24, minus 6 and positive 4, minus 4 and positive 6, minus 2 and 12, 2 and negative 12, 8 and negative 3, negative 8 and 3. So you can see here we have quite a lot of solutions. If you find it early on, you don't have to write them all. So here we know that these don't add to give negative 2, but this negative 6, 4 does. So now all the other ones are also incorrect. You can check that if you want. So this will then give us our factorised brackets. We'd have x minus 6, x plus 4 is 0. We then need to make each bracket equal to 0. That will give us our first solution of x is 6. Make our second bracket equal to 0, and this will give us our second solution of minus 4. Part B, very similar technique. We're timesing to make positive 18, and we're adding to make negative 11. So therefore we know to times to get a positive, but add to get a negative, both numbers must be negative. So we've got minus 6 and minus 3, minus 9 and minus 2, minus 18, minus 1. Again, only one of these will add to give minus 11. So we've got x minus 9, x minus 2 is 0. Again, we'll make each bracket equal to 0. And that will give us our first solution, x is 9, and our second solution of x is 2. Okay, so having a look at question 6, you will notice that this question is presented slightly differently to how you've seen it before. You've got this additional equals 10 on the end, and we know that we've been solving all of these quadratics previously when it's equal to 0. So actually the first step you need to do when you complete this question is make sure that it does equal to 0. So you're going to subtract 10 from both sides. That'll leave you with x squared minus 7x minus 44 is equal to 0. This is now the quadratic that you are going to factorise and then solve. So you times to make the negative 44, and you add to make the negative 7. Now we write down our factors of negative 44. We know that one must be positive and one must be negative. So here we can clearly see that our solution must be negative 11 and positive 4. We can now solve, making each bracket equal to 0 and getting our two solutions. So looking at question 7, this is similar to question 6. We've got it equal to 2x minus 7 on the right hand side. We need to make this equal to 0. So we are going to subtract 2x from both sides. That would leave us with x squared minus 10x. And we need to add 7 to both sides to get rid of the negative 7. 14 plus 7 is 21. We now factorise and solve like we've previously done. So we are timesing to make 21, and we're adding to make negative 10. So we know we're timesing to make a positive number, and we're adding to make a negative. That tells you that both numbers have to be negative. So we've got negative 21 and negative 1, negative 7 and negative 3. You can see that negative 7 and negative 3 works, so therefore in our brackets we have x minus 7, x minus 3 is equal to 0. We make each bracket equal to 0. That gives us one solution of x is 7, and our second solution of x is 3. Our final question. This is given in a context. It tells you that the cuboid has a volume of 924 centimetres cubed, and it has these three dimensions. It wants us to show clearly this quadratic. We've got to get that using just this information here. So we know that volume means we've got to multiply our length by our width by our height, and it's told us these three dimensions. We've got 4, x plus 1, and x plus 11. 4 times x plus 1 times x plus 11. So let's deal with the first bit here. We've got to do 4 times x, which is 4x, and 4 times 1, which is 4. That now leaves us with double brackets, which we can expand. We would get 4x squared plus 44x plus 4x plus 44, which if we simplified, we'd get 4x squared plus 48x plus 44. And this is what our volume is equal to. So we can write that equal to the volume which is stated in our question, which is 924. What we now need to do is make it look like the answer in the question. So we're going to subtract that 924 from both sides. That leaves us with 4x squared plus 48x minus 880. You can now see it's starting to look like the equation above. However, we've got this 4x squared, and they've only got this 1x squared in their answer. So we now need to divide each of the three terms by 4. That leaves us with x squared plus 12x minus 220 is equal to 0. We remember to divide both sides by 4 so that we don't change our question. It then wants us to solve the equation by factorisation and then writing the dimensions of these. So we now need to solve this quadratic. We are timesing to make negative 220 and we're adding to make 12. So we're looking for two numbers which multiply together to give this negative 220, but add together to give 12. So you're thinking of two numbers which times together, which to give 220, but have a difference of 12. So thinking about this carefully, so you don't have to list every factor pair, because this would take you a long time, we would have negative 22 times by 10, and negative 10 times by positive 22. These two factors have a difference of 12, and they times together to give negative 220. The first pair adds to give negative 12, the second pair adds to give positive 12. We have therefore found our roots, so we can write in our brackets x minus 10 and x plus 22 is 0. We can then solve this by making each bracket equal to 0. That will give us our first solution of 10 and our second solution of negative 22. Now you've got to look at the context of the question. If we subbed in x is 22 into our volume, so x plus 1, we would get a negative length. We'd get negative 21. You cannot draw a cuboid with a length of negative 21. So this answer here we can actually ignore because it doesn't make sense in context of our question. And actually our answer that we have to use is this x is 10. We then know one length is 4, the next length is 10 plus 1, which is 11, and then our final length is 10 plus 11, which is 21 centimetres. And they would be the dimensions of our cuboid.